So what we're going to look at today is called a composite function. And in all honesty, these are my favorite things to do in high school. I thought they were just absolutely fun. Math nerd guilty right here. But a composite function, one way you will see these is they will say maybe something like g of f of x. Okay, that little o there in between the g and the f is, they say of. So sometimes you'll see a composite function that way. That actually is exactly the same thing as writing it this way. Okay, whichever one is closest to the x is the one that you start with. And what a composite function does is it actually has you do a function within a function. So kind of like you've always learned in math, you always do your inner parentheses first. This right here would be the first thing that you go through and do. You figure out whatever f of x is. Sometimes it'll say f of 2 or, different things like that. So what you're going to do first is you're going to evaluate inner function first. Okay, my pen is obviously not writing very well. Alright, and then after you would go through and evaluate that, which will probably make more sense once we actually look at one, then you go through and you do that second part. So you do g of whatever that last answer was. So then, use your answer. As the input. Sorry. Of the outer function. Which is, darn it. Oh, there we go. Which is g of x. I'll just make that just a g of x. Okay, so like I said, with a composite function, it's kind of a function within a function. You'll evaluate the inner function first, and then whatever that answer is, you'll plug that in for x into the other function. So let's go through and just take a look at a very, very basic view. So if you need anything from the screen, go ahead and pause it and switch screens. Okay, so oftentimes with composite functions, you'll obviously be given the function itself. So our f of x is x minus 2, our g of x is x plus 2. Now they commonly use f of x, g of x, and h of x. They can do them in any sort of order, it's just naming the functions. So this very first one I have over here, g of f of negative 5. Now when I go through and do those, especially if it's written with that little o of, remember that's not multiplication, I always go through and rewrite it, kind of like 2 and 3. This is the same thing as g of f of negative 5. You don't have to rewrite it. I do. It just makes it easier in my mind. So what I'm going to do is I have to do the inner parentheses first. I'm going to have to evaluate f of negative 5. So I'm just going to do that up over here, so it's kind of out of the way. If I were to figure out what f of negative 5 is, well, basically I'm going to be using the f function, but I'm going to be plugging in a negative 5 in place of x. So in my f function, I'm plugging negative 5 in for x, so that becomes negative 5 minus 2, which in this case is negative 7. So that means, instead of writing an f of negative 5 here, I'm going to write a negative 7, because I already evaluated what f of negative 5 is. So now, what I need to do is g of negative 7. So in my g function, I'm going to plug in negative 7 in for x. So if I plug in negative 7 in for x, it is a negative squared, so it does need to be in parentheses. So negative 7 squared, which is 49. So that means the final solution of this is 49. So that's a composite function. Again, you evaluate the inner function first, and whatever that answer comes out to be, that's kind of the input for your next function. Alright, so if you need anything from right at the top there, I have f of negative 5 and negative 7. Go ahead and get it. I'm going to erase it off of there. Okay, so let's get rid of these, because I'm going to use that space more than likely again. There we go. Alright, so now I'm going to do number 2. So this is g of 3, so I have to do that inner function first. So I'm going to leave this f part of the function alone. I'm going to figure out what g of 3 is. Well, g of 3 just means in my g function I'm going to plug in 3 in for x, so that becomes 3 squared. Well, we know that 3 squared is equal to 9, so that means that this is going to become f of 9. So now, in my f function, I'm going to plug in a 9 in for x. So if I plug in a 9 in for x, I get 9 minus 2, which is 7. So that means the final answer for this one is just 7. Okay.
Mama, I was trying to poop.
Oh, hold on. Let me pause. Alright, sorry about that. I have a son who doesn't feel good. Okay, so back to number 3. Again, we're going to do our innermost parentheses first. So we're going to do g of x. Now, in these cases, x is not specified to be a certain number. So in that middle space, you're just going to put g of x. Well, we know from up here that g of x is x squared, so you're just going to put an x squared in that space. So now, in our f function, we're going to plug in an x squared every place we see an x. Okay, so I'll say that again. So in our f function, we're going to plug this in place of x. So this one, instead of x minus 2, it's going to be x squared minus 2. And since we have no value for x, that is our solution to that one. Alright, so if you need anything from the screen, go ahead and pause it. I'm going to switch screens. Okay, so we're on to another 2 examples of composite functions. And if you want to try these on your own first, you can pause the video, try them, and then hit play again and see how you did. Alright, so this very first function, again, when I see one like that with the little o, which means composite, I always rewrite them. So this is the same thing as g of h of 2, and we're going to be solving h of 2 first. So that means in my h function, I'm going to plug in 2 in for x. Now I'm not going to go through all the steps that I went through last time off to the side. We're just going to mentally figure out how to find h of 2. So in my h function, if I plug in 2 in for x, I get 2 squared, which is 4. 4 plus 4 is 8. So now, in my g function, I'm going to plug in an 8 every place I see an x. Well, so that becomes 2 times 8, which is 16. So the solution to number 1 is 16. Alright, moving on to number 2. Again, I want to go through and find g of negative 1 first. So, again, I'm not going to go through all those extra steps. We're just going to plug them in mentally. So in my g function, I'm going to plug in negative 1 in for x. So 2 times negative 1 is negative 2. So now in my h function, I'm going to plug in a negative 2 every place I see an x. So, and just be careful with the squared. Anything negative, when it's squared, it becomes positive. So negative 2 squared is a 4. 4 plus 4 is 8. Alright, our third problem. And this is one of those where x is not defined. So in my, I'm basically going to plug in h of x there, which is x squared plus 4. So now, in my g function, I'm going to plug in x squared plus 4 every place I see an x. So in my g function, that was just 2 times x, is now going to be 2 times x squared plus 4. And for this one, I can simplify that out. Be 2x squared plus 8. Okay, so those are all some easy, basic composite functions. And you may have some of those just basic composite functions on the math exam, possibly more for math 2 or 3. I did find one that was a little more challenging on an old math 3, so I'm going to go through that problem with you. So if you need anything from the screen, go ahead and get it. Okay, so this is more of a challenging problem. It says, if f of x equals x to the a, where a is a positive real number, if f of x is 64, then a satisfies a, b, c, d, e. We just have to figure out basically which one. Okay, so you can see larger composite functions such as this one, and with this one, as you go through and start trying to solve this, what I would go through and do if it was me, it says a is a positive real number. So when I look at my options, I have a says a is between 0 and 1, b says a is equal to 1, and then you have d, which is a is 2. So I'm going to go through and try if my a is equal to 1. I'm just going to check it out and see kind of what happens. Well, if my a is 1, then my f of 2, looking back at this function up here, if my f of 2 is going to be equal to 2 to the first, which is just 2. So now I know what f is, or f of 2 in this case, and I could go through and start solving this if I wanted to. So in my function, this one is f of f of f of 2, because we're trying out a 2 in this case. So let's say, I think I have all my functions in there. Okay, so now with this one, I want to go through and find f of 2. Well, f of 2, which is equal to 2 to the first, so which is going to be just 2. Well, kind of the same thing starts happening again. F of 2, well, which is 2. And let's say, and then this case again, it's going to equal 2. Well, my original problem basically says that doing this is going to equal 64. And again, I just picked 2 for x. I mean, you could have picked something else. I'm just going through and trying stuff. So 2 is obviously less than 64. So in this case, it's definitely not going to be b for this one. And since when my a is equal to 1, I end up getting a number less than 64, significantly less than 64, so I definitely know it's not going to be a at that point. So I'm going to try the same thing now if a is equal to 2. And I'm going to leave my x value, obviously the same thing that I had before. So if I try to find my f of 2, well, if I plug that in, I get f of 2 equals 2 to the second, which is going to be 4. So my f of 2 is equal to 4. So if I start solving this thing, again, I'm going to go through and do that innermost parenthesis part first. Well, I know from up here my f of 2 is 4, so that's going to become a 4. So then I get f. Now I've got to simplify what f of 4 is. Well, I'm going to do this down here. So f of 4 means that it's going to be 4, and I'm trying out when a is 2, so the 4 to the second. So my f of 4 is going to be 16. So now I've got to solve f of 16. So f of 16 would be 16 squared, which is 256. So this comes out to 256. So if my a, most definitely my a cannot be equal to 2, because my problem said that this was supposed to equal 64. Well, 256 is a lot bigger than 64, so it can't be that one. And it can't be anything bigger than a. So my only reasonable option is c. My a value is going to have to be somewhere between 1 and 2, because 1 it came out to 2, and at 2 it came out to 256. So these type of problems just kind of go through, pick out easy numbers to work with. Like in this case, 1 sometimes has, especially with exponentials, exponentials, it simplifies a little differently than what regular numbers is. That's why I chose when x is equal to 2. And in this case, like I said, I looked at my multiple choice options and went, okay, I'm going to test out a equals 1 and then a equals 2, and came out to my reasonable answer. Okay, so let's try, let's see, I was thinking of one earlier. Actually, no, I think I'll leave that for the answer choices, but hopefully this kind of helped give you an idea what a composite function is.